It's a gathering for inventors, tinkerers, and do-it-yourselfers of all ages.
You can make almost anything. If it fits in this box, you can make it.
At the 2012 Maker Faire in New York City, attendees not only had the opportunity to build things, they also had the chance to experience an innovative way of making things called additive manufacturing, or 3D printing.
Look at this! It's a 3D printer! That's cool.
3D printing has grown in many different directions, and most people, when I visit them, don't realize it had anything to do with inventing three-dimensional printing.
Two of the creative forces behind 3D printing technology are NSF-funded scientists from the Massachusetts Institute of Technology, Michael Sima and Emmanuel Sachs. Their work in the field of additive manufacturing started back in the 1980s with the goal of giving people a more efficient way of creating prototypes or potential versions of a product.
One of the slow steps was the time it took between a design on a computer to actually getting something that you could test, that you could prototype, put in the hands of a customer, for example, for them to try before you went and manufactured them.
Traditionally, manufacturers have used a subtractive process to create prototypes. Like a sculptor chipping away at a statue, the subtractive process begins with a large piece of material that is cut, drilled, or whittled down. The additive process works in reverse.
Additive manufacturing was an attempt to get around that problem by making parts from the ground up, not from a piece of solid object, not cutting it out from a solid object, but making layers of a material in thin sections.
Through their collaboration, Sima and Sachs invented an additive manufacturing technique and coined the term 3D printing. In essence, a three-dimensional digital representation of an object is created using a computer. This image is then mathematically sliced into thin horizontal layers. Each layer's data are sent to the printer. A layer of powdered material that the object is to be made from is spread over the print bed. The inkjet head returns, printing a liquid that reacts with the powder to make it bind.
Depending on the material set, the 3D printing process is based on printing a glue, if you will, to hold that powder together.
Layers of powder are spread into a printing bed that sits on top of a piston. The inkjet moves across the building bed and prints in 2 dimensions across the horizontal X and Y axes. The layers are deposited one on top of the other, and as the piston moves down along the vertical Z axis, it forms the 3rd dimension.
At the end of the process, your piston is completely filled with powder, but only certain volume elements of the powder that are in there are held together, so you can just reach in and shake out the part.
In 1993, Sima and Sachs began filing a series of patents with the United States Patent and Trademark Office for the 3D printer. Companies have licensed some of these patents to produce their own 3D printers. For the two researchers, patenting their technology has given them a 20-year window that allows them to protect and make money off the intellectual property.
I like to tell people it's like putting a fence around your property. It tells you in language what's your property, your idea, versus somebody else's.
Today, several 3D printing techniques exist, ranging from a printer head that dispenses melted material into layers to a laser that fuses material together to form objects of great precision and durability. 3D printers are already used in automotive and other engineering fields, and healthcare. While the 3D printer was originally developed to make prototypes, Sima first realized the invention had a much broader value when an artist used the technology to create a model of a mosque.
The thing that was most interesting about that was that the rooms were inside this mosque. That was my first inkling that people would want to use this not for prototyping something they could make other ways. They'd want to use these technologies to make things that they couldn't make any other way.
And therein lies the most innovative part of 3D printing. It is giving scientists, engineers, and even backyard inventors a tool that can turn their own ideas into a reality.